Today we're looking at lesson 4.7, which is inverse linear functions. If one relation contains the element a, comma, b, then the inverse relation will contain the element b, comma, a. So as you can see, it looks like if you're trying to do the inverse relation of a relation, which is an ordered pair or a set of ordered pairs, then you would just switch the x coordinate with the y coordinate. So if I were to find the inverse of this relation, I would switch each coordinate and rewrite the ordered pairs. So it would look like this. And that would be the inverse of the relation that I was given. Here we have it in table form. Again, it would be the same idea. So if you were to do the inverse relation of table form, you would just flip the x coordinates with the y coordinates. And that would be the inverse of the relation. Here we're asked to graph the inverse of the relation. So we're given a graph with 3 clear points. So the first thing we would need to do to be able to graph the relation, the inverse of this relation, is to get the equation of the relation. Or I could get each ordered pair and graph those 3 ordered pairs as inverses. So the first ordered pair would be 1, 2, 3, 4, negative 4, 2, right here. And then I would have negative 1, 1 here. And 2, 0. And if I wanted to do the inverse of this relationship or relation and graph it, I would just need to graph these 3 ordered pairs instead. So my points would be at 2, negative 4, and 1, negative 1, and 0, 2. And then I would draw my line. Let's change. So the yellow line would be the inverse of the graph. If I were to do the graph here, the inverse of this graph, I would do the same thing. Find out at least 2 ordered pairs. This gives me 3. So I have 2, 2, negative 1, 1, and negative 4, 0. So I would graph the inverse by flipping the x and y coordinates. So my new points would be at 0, negative 4, 1, negative 1, and 2, 2 would stay actually the same. So it would end up with the pink line as my inverse of the relation. Here is if you're given a function and you're asked to find the inverse function. So it's 4 steps that you would follow. The first step would be to replace the f of x with y. Then you would switch y and x. Then you would solve the equation for y. And then finally place f to the negative 1x to indicate that it's the inverse function. And you'd put that in for where y is after you solved for y. So we're going to follow those 4 steps here. So the first step would be to replace the y with, or the f of x with y, and then we switch the x and y's. And then now we solve for y, so we have to get y by itself again. So I would add the 12 to cancel out the 12. And then I'd have to divide everything by 4 to cancel out the 4. So if I simplify that, I would have y equals 1/4 x plus 3. And my final answer has to indicate that it's the inverse, so I would write it as f to the negative 1x equals 1/4 x minus 3. And this would be my final answer. I'm going to do the same thing here. Replace y for f of x. Switch x and y. And then solve for y. To cancel out a fraction, remember you multiply both sides by the reciprocal. So I'm going to multiply both sides by 3, or 3 over 1. That gets y by itself. And then I'm going to distribute the 3 to both parts here. And I have y equals 3x minus 21, and then I would replace the y to indicate it's the inverse with f to the negative 1x equals 3x minus 21. Again, I don't know where this stopped, but what I just did is I found the inverse of the function in pink, and this is what I got. So if the next question is asking me to figure out what x and c to the negative 1x represent. So I need to figure out what they represented in the first place. In the first place, you had total cost would be c of x. So if it's c of negative 1x, that's going to be the inverse. So I'm going to switch the total cost to represent x instead of c of x, and then I'm going to represent the c to the negative 1x, the inverse part, with the number of miles. So x would be now the total cost, and c to the negative 1x would now be the number of miles. And the third one is how many miles did Peggy drive if her total cost was $34.99. We're going to use the inverse function and basically solve for c of negative 1 to the x. So we're going to plug in for x $34.99. So I have this is the function I'm looking at, the inverse function that I created. So I'm going to plug in, since x now represents the total cost and c to the negative 1x now represents the number of miles, I'm going to plug in the cost for x and solve. So the number of miles would be $34.99 divided by 0.3 plus 66.6. So it's about 183.23, so we can say about 183 miles. And that concludes lesson 4-7.